All right, we're going to take a look at a few examples from lesson number 2, and this is on simplifying rational expressions, part 2. So just remember from the first lesson that if we're trying to reduce or simplify rational expressions, it involves canceling the factors and not the terms, which means that we got to factor these first. So the first one we're going to look at is 4t cubed minus 9t divided by 2t squared minus 3t. And so the first thing we want to do is we want to factor the top, so the numerator and the denominator, in order to see what common terms there actually are. Or sorry, what common factors there are, not terms. So if I look at 4t and 9t, 2t squared and 3t, they're all divisible by t. And so if I'm looking at the top, if I pull t out of 4t cubed and 9t, I'll be left with 4t squared minus 9t, or sorry, not 9t, but 9 on top. And on the bottom, if I pull out the t, then I'll be left with 2t minus 3. Now you might notice that 4t squared minus 9 is a difference of squares. So I could break down 4t squared minus 9 so that it has a common factor with 2t minus 3. In which case I'm going to be left with 2t minus 3 and 2t plus 3. And that's all going to be over t times 2t minus 3. Now, if I think about what t can't equal, well, t can't equal 0, and it can't equal positive 3/2 if I set both of these equal to 0 like we were doing in previous units. And if I think about what my final simplified expression is going to be, well, 2t and 2t minus 3, those are factors that can cancel out, as well as t and t are factors that will cancel out. So my final answer is going to be 2t plus 3. However, because I have these variables on the bottom, t cannot equal 0 or positive 3/2. So with these next two examples, B and C, we're going to approach exactly the same way. We're going to start by factoring them. And so if I have 2x squared plus 5x minus 3 and 2x squared plus x minus 1, I'm going to have to factor these using decomposition. And so if I decompose this, then I'm looking at what multiplies to give me negative 6 and adds to give me 5. And so I'm going to break this down into 2x squared minus x plus 6x minus 3, because 2 and negative 3 is going to give me negative 6, and negative 1 times 6 will give me negative 6. And then on the bottom I'll have 2x squared minus x plus 2x minus 1. And then I got to go through the process of grouping these and then simplifying. So this is like what we were doing in 2 previous units ago, as well as our last units. So I'm going to factor both of these. So again, my numerator and my denominator, which will leave me with x, 2x minus 1, plus 3, 2x minus 1, over x, 2x minus 1, plus 1, 2x minus 1. And yeah, from here I'm going to be left with, well, 2x minus 1 times x plus 3 on top, and 2x minus 1 times x plus 1 on the bottom. And if I simplify this, I'll get rid of those. And remember that we have to use my previous denominator in order to set my values equal to one another. And so my values of x will not be able to equal negative 1 or 1/2. This next one, notice how we have a to the power 4 and a squared. That means you're going to have to factor this one using substitution as well as decomposition. For these next ones, express in simplest form, stating the values of the variable for which the expression is not defined. Well, if I have c minus 4 and 4 minus c, I can factor this. So if I have c minus 4, I can rearrange this so it's written as negative c plus 4, in which case I can divide or factor negative 1 out, which leaves me with c minus 4, or negative 1 in simplified form. However, c cannot equal positive 4 because that will make it equal to 0. With these next two examples, we solve them the exact same way, so we're solving these by factoring as well. This next example we're going to look at, it's more of an application of this math, and so we're given a rectangular field, and with this rectangular field we are given the area. So there's the expression for my area, 12a squared plus 25a minus 7, and we're also given the length. So we're told that this is 3a plus 7. What we want to do is come up with an expression in order to represent the width of the field. And so I know that area for a rectangle is length times width, and if I'm looking for the width, I know that area divided by length would give me my width. And I have my expression for my area, which is 12a squared plus 25a minus 7. And if I divide that by my length, that's going to be 3a plus 7 in meters. That's equal to my, not to my area, sorry, to my width. And so in order to solve for my width, all we need to do is simplify. And so if I simplify this, I'm going to be left with, well, I know I have 3a plus 7. And my other factors, well, 3a and 4a would give me 12a squared, and negative 1 divided by 3a plus 7, which leaves me with my width of 4a plus 1. Sorry, 4a minus 1 being the width. Next thing we got to do is find our perimeter, and so in order to determine the perimeter, we know that, well, the perimeter is equal to 2 times the length plus 2 times the width, or 2 times 3a plus 7 plus 2 times 4a minus 1. If we combine our like terms, then we're going to have 6a plus 14 plus 8a minus 2. And our perimeter is then, that's going to leave us with 14a plus 12. And we know that our perimeter is 54. And so if we end up solving for a, I'm going to have to subtract 12 from both sides. And in subtracting 12 from both sides, I'm going to be left with 42 is equal to 14a. And if I divide by 14, a is equal to 3. Finally, the field has to be treated with fertilizer at a cost of $2.40 per square meter. Calculate the cost of the treatment. Well, my area is equal to 12a squared plus 25a minus 7, which is equal to 12 times 3 squared plus 25 times 3 minus 7. And if you crunch that in your calculator, you're going to get an answer of 176 meters squared. And the actual cost is going to equal 176 square meters times $2.40, which is going to come out to you again $422.40.